Started. Okay, so let me share my screen. Okay, hope you are able to see my screen. Fine. So let's begin with the our statistical journey. Okay, fine. So okay, I have not updated this particular slide. Okay, so sorry about that. Okay, no issues. So okay, fine. Now, yeah, this only I have updated. 16th August, 17th August, 18th August. Today is the 18th August. So we have started our journey with the statistics. Fine. Okay. In the first class, we just gave the introduction on the statistics. Then we looked into the different the statistical technological terms like population and sample. And yeah, so population and sample and sampling also. If time permits, maybe probably I want to take a lab on this. Okay, it means that once we have a data set, not today, probably maybe tomorrow I will take the some few the basic fundamentals that we cover in the statistics, so that we can do the same correspondingly in the lab also, so that we will get a good understanding. So for example, now if there is a data set, if you consider this as a population, then how we can derive the sample out of it, and how we can calculate the sampling error for any of the considered statistic. Maybe it could be a minimum, maximum, or any kind of mean or standard of deviation. Okay, so that also we can do it. And we considered the sampling methods mainly on the random sampling we did, then the systematic sampling, then one more was the stratum. Okay, uh, stra stratified sampling. So here maybe one or two sampling methods also will take an approach, and let's see how we can be done in the Python coding also. Okay, so that that understanding will be clear. Then what all things we covered? Then we jumped down into the classification of the statistics, broadly classified into two types. One is the descriptive statistics, and then more is uh, the inferential statistics. Still, we have not started the inferential. We are still into the descriptive statistics. In the descriptive statistics, mainly we covered two things. One was the measure of center of tendency, and such the second was the measure of dispersion or measure of the variations. Okay, so here in this we covered mode, mean, and median. In this we covered the range, interquartile range, then the variance, then the standard of deviation. Okay, yeah, fine. Yeah, this all what we covered in the last class, and extensively we discussed about most of the topics that are related to mainly on the descriptive statistics. Fine. So today what we'll do again, one more important topic which I want to cover in the same thing before I getting into the inferential statistic and the descriptive statistics. Okay. So I think this session I would make it short. So I want to log off little early. Just I want to cover only the correlation analysis, how we can do it, and that is correlation analysis very important topic as part of the descriptive statistics. Okay, so what is my agenda today? So what is the correlation, and what is the scope of the correlation, and what are the types of correlation? Here I listed only three, and actually we can list it to five. We'll see that. Okay, the positive and negative and the zero correlation, and what are the methods of studying the correlation? Means that how we perform the correlation analysis. Okay, so basically there is a like how we did it for standard of deviation. Simply we can do it for how we can calculate the R, and also we can do it with our the graphical mode. So using a scatter plot, you'll be able to get an idea that whether how the variables are correlated to each other. Okay, yeah. So let's get into the definition of correlation. What do you mean by correlation? Correlation is the degree of association between two or more variables. when we start our analytical process, okay, mainly on the pre-processing part, when we want to understand the data set, okay. So as you know this, when I say the data set, it is a collection of the variables, okay. When we have the variables, we want to know how each variable are related to each other. This is a very much important step in the pre-processing part, or you can rather, I would say, exploratory data analysis. Okay, so here, like A, B, C, okay, how individually each of the variables are related to each other, and how they are related means, like, let's see, that means that they are actually they are we can say one is dependent on the other. Suppose both the variables are independent to each other, then there will not be any correlation. Okay, so at least what you mean by correlation, that is association. What kind of association we're looking for? So for example, if there any change in one variable, and that is going to affect the other variable, okay, that is vice versa. If two or more quantities vary, so that movements in one tend to be accompanied by the movement in the other. Okay, okay. For example, now suppose think that there is a height and weight. Okay, so rather I would say that these are truly associated. If the height increases, the weight will also increase. Okay, so something like this. So these kind of variables, there will be a correlation, but we want to know these are the known variables, but ultimately in a real time, the variables will be very much typical. So in that case, we need to understand the what kind of correlation exists in the data, so that with an understanding, we need to choose or choose certain modeling for us, what in the case of what kind of problems we are trying to solve. Okay, yeah. Then there is a coefficient of correlation. Why this coefficient of relation? Because we need to measure this. For example, now there are two variables are there, like this is x and y. When I want to know the what is a correlation, I should have certain measure, like how much they are correlated. Are they correlated perfectly? Means that if certain change I have done it in x, that is going to affect the y, or how much change it is going to affect. Because if I make a bigger change, whether it is going to affect a smaller change here in the y, or if I make the small movement in the x, whether that is truly going to affect in a very big proportion in the y. Okay, so this particularly we need to mathematically measure that correlation. Okay, so um, so that is done by your coefficient of correlation, that we will define how we can do that. Okay, okay. So that's what meaning. The correlation is the most popular and statistical measure that we saw, particularly in the case of when we want to indicate the relation between two or more variables. Okay, and mainly it is concerned with finding whether or not the relationship exists. One point, what is the degree of the correlation? Okay, whether it is a positive correlation or a negative correlation or any kind of correlation is that. And direction of the relationship within the variable. Okay, then relationship is a strong or weak. So these are the concern, like these are things which we want to know in the data set. Okay, yeah. Okay, what are the examples? If I give that, I just gave the weight and height. Similarly, for example, now if you take the now years of experience, definitely the income will be more. So that's what is the understanding. So it means that if the years of if a years of experience is more, it's a default that there will be a little more income in his salary or something. Okay, and similarly, the relation between about the amount of rainfall and the yield of rice. Okay, so again, the if the rainfall is more, then the yield of the rice will be in a positive. Okay, that's what. Then again, the price and the commodity, how they are related, and relation between the nature of work and the motivation of the work, and relation between height and weight, as I said. Okay, so these are simple examples, and but these are already just get an understanding on what is the correlation here. But in a real time, for example, you take through the IoT. So if you are collecting a huge data, maybe in the terms of big data, and this big data becomes when a lot of your sensors are collecting the data in the real time. Okay, so in that case, this is not simple like 1 or 10, it will be in terms of thousands. Okay, so 1,000 variables would be here. Then in that case, we need to have very good understanding on how each variables are related to each other, and how what is the outcome of the correlation? Is there any way that using the inferences of the correlation, is it possible that I can cut down this number of variables? Maybe, for example, for the selection of the attributes. Okay. So the inferences, that's what we need to come out of with the result, like what is will be my action on my inference. Okay. So basically that would help actually in the when we perform the correlation analysis as a beginning step after cleaning and inputting all our data set. Once the data set is ready, then we go for performing this correlation step. Okay. And what is the scope of a correlation? The existence of a correlation between two variables imply that either the tend to increase or the decrease. Okay. That is the scope of the correlation. Then an increase in one accompanied by the corresponding decrease. Okay. So that is also there. Correlation does not answer the question or like why and the cause and effect, obviously, because we just see the only that whether there is any change. If I make some small changes to the one variable, that how it is going to affect the other variable. The only thing, only that much I'm trying to study here, but I will never try to answer why there is a change. So that is not the point over here. Okay. And it may be due to the following reasons. Okay. One of the variable may be affecting the other, and correlation calculated from the data on demand and price will only showcase the degree of the association. Demand and the price is high. That's an example. Okay. And sometimes what happens, so there are A and B are there. Okay. So we see that A, when we increase a small increase, there is a effect of B, but this could be because of some other variable C. Okay. Because C is actually affecting B, because A, we are making changes. That is the indirect way of doing it. Okay. So because they are not directly related to each other. In that case, we call them as a nonsense correlation. The two variables may be acted upon the by the outside influence. Now the C is acting as an external. Okay. So that is a because now in our environment we are studying only the B, but out of we are not studying the C, it is out of scope. But when we have kept the C as out of scope, but still it is affecting the B, it means that in our closed environment what we are making an experiment, so the other variable which we are not considered, that is going to affect it here. So that is the reason we call this nonsense correlation. Then the high value of the correlation may be due to the sheet coincidence. So maybe it happens sometimes there will be a pure coincidence. Okay. So that also you need to analyze it properly, whether you need to consider such variables or not, which actually because of the some by chance, so they are very high correlated. Let's getting into the types of correlation. So what are the types of correlation? How you are going to do make the classification? Okay. So basically that depends on three things. Okay. This is one, and this is 2, and this is 3. On the basis of direction of change. Okay. Means that if I, this is X and this is Y, if I make small change, here it will be a big change. If I make this big change, there will be a small change. Okay. So means that there is a direction of change, whether it is a positive correlation or a negative correlation, a perfectly positive and a perfectly negative. Okay. What is perfectly positive and perfectly negative? I'll see that what it is. Then we have zero correlation, means there is no relations exist between the variables. That's what is the zero correlation. And again on the number of variables, that's what when you are performing this when we are performing a correlation between only the two variables. Okay. So that we call as a simple variation, the simple correlation. Okay. Here is a simple correlation. Then if we are doing more than two variables, like for example in the case of the exploratory data analysis. Okay. What generally what we do, there is a seaborn pair plot is there. Okay. So when we run this pair plot for certain data frame, automatically suppose there are 10 variables in the data frame, all that 10 by 10 I will get the correlation matrix for me. Okay. Like something like this as a matrix. It means that what we are doing, it's a multiple correlation what we are trying to see and analyze and come up with certain inferences out of it. Okay. So this is one point. Then what about the partial correlation? The effect of only two is studied while others are kept constant. Means that in a closed environment, for example, now I want to study, I have around I think that there is a four variables are there, but to my study I'm just considering only AB here, and C are not at all considered. Okay, because I have kept it out of it. In that case, this becomes a partial correlation because I have to ensure that the C and D are not affecting the A and B. Okay, so this is one important topic when we do the time series analysis. Okay, so where we have to study the correlation between our the same lagged data. Okay, so maybe I'll discuss in future what is mean by lagged data and all that. Okay, fine. Just remember that there is a partial correlation exist. Then on the basis of proportion, there is a linear correlation and there is a non-linear correlation. Okay, the amount of change in the constant ratio, the linear regression. For example, now think that I am regressing y x. Okay, this is x and this is y, and the whether it's a linear regression, something like this. Okay, and the amount of change in the constant. For example, if I make any changes, I want to study what is the change here. Okay, that is perspective of linear, and again there is a non-linear correlation also, something like this. Okay, these are the types of correlation, but we'll concentrate on particularly these five things here now. Okay, so positive correlation, negative correlation, then perfectly positive correlation, perfectly negative correlation, then you have a zero correlation. Fine. What do you mean by positive correlation? Okay. When two variables move the same direction, when the correlation between these two variables is to be positive correlation. It's very simple. When I'm changing x, definitely where there is a change in x means there is a positive change in x. There is a due to this change, there is a positive change in y also. Means that there is a positive. It means that if I increase something here, there will be increment here. So obviously there I can, if I go with the linear, I would have some line something like this. Okay, so there will be some scatter points over here. Okay, these are my points of x and y, and if you see this, the change would be something like this. Okay, when the value of one variable increases, the value of the other also increases at the same time. So for example, now you take this is a training and the performance. If I take this as training and the performance. If I start it from 300, so 350, all that till up to 400 if you take it. So here it is 30, 40, 50, 60. If you take these points, so something like this, you will get it. Okay, these are the points. It means that if you see that one by one the point, there is an increase in the the trend. Okay, there is an increase in the trend. That is because of the positive correlation. And you can see this. Yeah, this is a good example. This is a positive correlation. Okay, then there is a negative correlation. What do you mean by negative? There is a reverse of positive. Means that if I change x, there will be a negative change in the y. Okay, so if that is the case, if a negative change in the y, it means that we are coming down. For example, now it would my points would be something like this. This is a negative change, means that I'm coming down. Okay, so in this type of correlation, two variables move in the opposite direction. When I make positive change in x, there will be a negative change in y. When the value of one variable increases, the value of other value decreases. Okay, so this is a good example, relation between the price and the demand. You take any one product. Okay, when I increase the cost of the price, automatically my sale will come down. Okay, so demand also will come down. So again, this kind of example would be, there is a change in the price, means that you are going to increase the price, then automatically the demand will fall. That is a negative correlation. You can see this graph. Yeah, perfectly positive correlation. Okay, so when there is a change in one variable and there is a equal proportion of change in the other variable, say in the same direction. Okay, so first thing is just consider only the positive correlation. Okay, so now if I put the graph something like this, as I said, there is some change in x, there will be change in y. Let's not consider how much change. So if I do this, there could be something like this. Okay, or it could be something like this, or it could be something like this. Okay, but there is a always there is a upside, means that in the positive change. But in this case, there could be multiple things, right? So but what we have to consider, these two variables set to a perfect positive because there is an equal proportion of change. Means that if I increase by one, there will be increase by something this much equal. So ultimately we'll have a 45 degree here. Okay, so if this is 90, 45 degree, the I can see the line over here. Okay, so that is a perfect positive correlation. It should come something like this. Similarly, between two variables, the negative correlation means that if you change one direction, the other variable will be have the negative effect. Okay, but with the equal proportion. That's what we are saying. Equal proportion. Equal proportion. So good example would be something again perfect. Okay, yeah. Then zero correlation means that there is a data here x and y, and since they are truly independent, they does not depend. So if the dots, the if the data is scattered something like this, then will not be able to make out what kind of change is that. Okay, so there doesn't exist any kind of correlation in this. So that's what we call as a zero correlation. The example would be something like this. Okay, it's an independent variable and this is an dependent variable. If you consider also how the data points are got started, and you can see that there is no correlation at all because you cannot make out anything in this. Okay, yeah. And let's see what are the methods of studying correlation. Means that we know what is a correlation. Now we classified into the 5 types. Okay, but we want to know that actually how, what is the method of studying it once on the data set is given to it. So basically there are two methods. One is a graphical method. In the graphical method, as I said, we'll be using the scatter plot. Okay, using a scatter plot, by just looking into that pictorial representation of the data set, I can come up with like whether I'll be able to tell, or I can come up with my inference saying that whether there exists any correlation in my data set. That is for the scatter plot. How about having any kind of algebraic method? Yes, there are different methods are there. The scatter diagram, then this is a scatter diagram which we explain in the graphical method. So again, there is a Pearson, Carl Pearson method, rank method, and concurrent deviation. So which I will touch upon this only, the Carl Pearson method. Okay, so how we'll do this? This is my Pearson coefficient correlation which we need to calculate. Okay, and basically what are the assumptions that it makes? Okay, so when it is going to calculate for measuring the linear relation between the two variables, okay, so it assumes that there is a linear relation between the variables. Okay, so this is x and this is y. I always consider there is a linear relationship. Non-linearity is something like this. We don't ever consider this because that is not an assumption of your Carl Pearson. It assumes there is a linear relationship. That is my first assumption. And the second assumption is that there is a cause and effect relationship. What do you mean by cause and effect? Means that there is some small change that is going to affect and make changes into the other variable. So that is a meaning of cause and effect relationship. Fine. So how you calculate this? This is the way we calculate it. Okay. So if I have two variables as x and y, this is product of x, take the summation of that. Then this is summation of x and the summation of y. Then you multiply this product by n and take the subtraction of this. So this is your numerator. Okay, and anyway, ready-made all that libraries available, just one by line of statement. So for example, this is my data frame where x and I have stored. Just if I pass one statement as df.core and passing the null, okay, no parameters are required, automatically it will give the complete correlation matrix for me. Okay, very simple. Okay, but at least we need to understand inside actually what it happens. And this is how we calculate the denominator. Okay, so it looks like complicated, but always you can do a certain kind of tabulation, and I'll give an example also here. Okay, so think that there is one test one score is there and test two score is there, and here I have 5 data points A, B, C, D, E, and this is what it looks like to me. Okay, the 5, 3, 2, 8, 6, and 12, 15, 11, 10, and 18. So if I go back and check this, first thing is that I need to get the product of it, then summation of s, summation of y. Okay, okay. So here, if you take this, what is the summation over here? Okay, again, anyway, we can do it all the calculations, no issues. This is what we have to do. Okay, if you take the this is required, this is required, x square is required for me, y square is required. Okay, so in that case I can generalize something like I need to xy. Okay, summation of x I have taken, I know what is n here, what is y here, then I need to get the summation of xy. So now this will be product something like 12 5 is 60, then this will be 75, then this will be 22, and this will be 80, and something like this. Okay, yeah, then give the, just go with the making a square of 5, then this will be 12 into 12, this will be around 144. Okay, so this will be 225, and this will be about 9. Okay, so these kind of computations we do it when we want to manually calculate the coefficient of correlation. Okay, so when we do this, this is already done for me. Okay, okay, fine. Now what I have to do, I have to take the formula, replace with that, and yeah, this is how it is being calculated. Okay, I'll take the formula and already I've calculated in my tabular, then I will just replace all those values. And what is my R value now? R value is minus 0.480. Okay, that this much I get it. So again, it purely indicates. Okay, first let's evaluate it. How much it would come in our the Python. Okay, based on that we can take a call. Fine. So this method we call that using this formula. Okay, this method is called assumed mean method, and this method is usable only when there is a large data set. Okay, when there is a large data set, if you are going with the manual calculation. But what happens, let's see, this is, yeah, and there is one more method is called, again this is very simple when you are calculating, if you compare to this formula, and this formula is very simple. Okay, so just you take x and mean, so this method is called direct mean method. Okay, so there are two things which you can calculate it by manually. Remember this. This method is called direct mean method because you are using the mean here. Okay. So this is usable when you have the small set of data. But here this is a assumed mean method. Means that I don't have any mean over here because I need to go with an assumptions of the mean. Okay, that's what it means. So in this case, let's calculate it in the IPython notebook. Okay. So what I have done here, I have taken the same test data what I have given already it in the my earlier data. Okay. The 53286. So I have the 53826 here. This is my test one. Similarly, I have a test two as this much. Then what I will do, this is my anyway. I have created a dictionary with the two the lists. Okay, so okay, fine. Now what I will do, now this is a key and the value pair in the dictionary. Now I will pass it in the my data frame. Now what will my index, now what I given a b c d e. So this is what my data will look like. That's what I had shown you in my earlier slide. Okay, so this is what it shows right now there. I made this as a complete data frame. Now once I have made this data frame is ready for me. Now only one statement I need to execute, df dot core. If I do this, let's see what will be my value. Before this, I have plotted the data. And do you see anything here? Nothing here actually. Okay. So there is a little bit of a positive correlation is there, or there could be a negative correlation also here. Okay. Let's see how it actually behaves. Once I do this df correlation and leave about this one, okay, because test one to test one, there will be perfect correlation. Okay. And test two to test two, because you are checking it for the same variable. We need to consider this much. See, this is here 0.0576 you have got. Means this is a different value what I have got it manually. Okay. Just make a note. Whatever I had calculated with that formula, I have a different value when I do it with the data frame correlation. That is because of here it is using the direct mean method. Okay. Let's calculate it manually by now direct mean method, whether we'll get the same data or not. Okay, so in that case, what I will do, I will take the test one and the test two. Then what is my mean here? Okay, if you take this df test one minus df test two mean, okay, x minus, this is my data. Now I calculated for the x. Similarly, I calculated for the y. Then I will take the product of these two. Okay, fine. So if I go back and check what is my direct method, so this is my direct method. Summation of x minus x bar, y minus y r, taking the summation of the total product. This product summation is required for me. Okay, so that is the reason the df product sum I have taken it here. So now that will become a numerator. Summation of x minus x bar, y minus y bar. Okay, so this is my numerator. This x by x bar you can see it here, y minus y bar you can see it here. Then take the product of both the two, then do the summation. Okay, the numerator, that is the numerator what I have got it. Okay, fine. Let's go back again. So x minus x bar whole square. Okay, x minus x bar whole square, take the summation. This is your square root. Similarly for y minus y bar whole square, and this is for y. Okay, so now let's check what will be my for the denominator. Okay, denominator is same thing. Okay, because what is my denominator, what I was doing here, x minus x bar, this will be square and taking a square root into the same thing. So that's what we require. X minus x bar is already we have, square this is what I get it. Similarly take the y bar, now take the summation of both. Yeah, then you take the square root of this. That's what we are doing here. np dot square root, np dot square root of that. Okay, for the whole sum. Then this will become two parts. This a and this part is b. I have to take the product of it, denominator b. So that's what I'm doing here. Then take the numerator and divide it. So this is what I will get it. Minus 0.0576 minus 0.0576. So this is what I got it from the data frame. Okay, and just ensure that in the data frame calculation or even in the numpy, we are using the direct mean method when you are calculating the correlation. That understanding you should have. Okay, and you should know that how we can calculate the correlation manually also, and how we can calculate the correlation by the the Python. Okay, so using the data frame. Similarly, we can do it to the numpy also. That is also same thing. Okay, and what is the ultimate interpretation of the correlation coefficient? Okay, so when there is very less, if it is less than 0.05. So in my case, almost it has come around minus something 0.05 something is there, because as we can see this, there is no correlation exist at all if you take this. Okay, because if I just make it and 10 to, this will be automatically 0. Okay, if I assume this, if I truncate this value, automatically this will be 0, because I will have a clear, there will be no correlation at all, because all the points are very much scattered. There is no glimpse of there is a correlation exist there, whether positive or it could be negative. Okay, and there is, if there is a high correlation, then this is a good. Okay, so but ultimately what we have to do, suppose for example there are 1,000 variables are there in the correlation. Once you do this, what is the intention of the correlation? For example, think that there is one variable which is highly correlated with the different variables. Then you consider only this variable in the modeling. There is no need of considering these values at all. Okay, because if this is okay, let's not discuss about that, because in future I'll discuss, because there are a lot of other things which I need to cover otherwise. Okay, fine. Then using the scatter plot, how we can do it? Okay, so as already you know this, like for example using that SNS dot, if I do the scatter plot, I'll be able to pass what is x and y, and I will get a scatter plot. Based on that, you'll be able to tell that whether there is a relation between variables or not. So that is one method. But before this, we need to know how actually it happens. If all the points lie on following the straight line, the correlation is perfectly negative, which we already saw it. Okay, so means that If all the points something like this, that is a negative correlation. If it is something like this will be your positive correlation, perfectly positive correlation. Otherwise, all these lines which comes something like this, then is a positive correlation. Some sorry, negative correlation. Something like this, it would come. Okay, so that is a positive correlation. Okay, fine. And if there is does not exist anything there, then all the points will be scattered and you will not find any kind of relationship between the variables. That is the reason we say that there will not be any correlation exist in those variables. Yeah, fine. Think today I wanted to cover even lab also, no problem. Okay, fine. Yeah, just discard it. Fine. I'll just come back to you. Okay. Pawan, any questions? Because today I want to make it little shorter. In my next class, I'll start the lab for all the statistics and up to this much, whatever you have covered, let's do the lab activities.
No questions.
Okay, understood, right?
Yeah, that's good.
Okay, thank you.
Sir, one sample resumes.
Resume, you told me, no? Yeah, yeah. Actually, I'm a lot of busy with that migration. So see, what happened? Then we moved into different companies, so they are doing some migration activity for all our data, whatever we have. So it's a little busy with that only. Okay.
Sir, tomorrow we have the class. Sir.
Tomorrow, let's consider that we don't have, but something like okay, for are you going outside anywhere?
No, no, sir. I'm not going.
Okay, even Vinay, what about Vinay? If he's see, I will say basically if I don't have any commitment, okay, then I will just message you by 4 o'clock. I will message. Okay, is that fine?
Yeah, okay, sir. Okay, sir.
Okay, yeah, okay then. Thank you. Bye.